Okay, chapter 9, we're studying two samples, like you have two groups. So in this first example, we have a newspaper article, and researchers are studying laboratory gloves, and they want to test if the vinyl has a greater leak rate than latex. So we have two things. We have our number for vinyl and the percent. So the number for vinyl is 294 and the percent is 62%. For latex, we're testing 294 latex gloves and 14% leaked and a 0.10 significance. Let vinyl gloves be population 1. So we're testing that H1, which is the alternate hypothesis, which is the same thing as HA. We're testing that P1 is greater than P2. P1 is vinyl. It said greater for vinyl than P2 latex. Okay, so anytime you use greater than, that goes in your H1, your alternate, and that makes the HO always has equal. Okay, to get our test statistic, we're going to go to Get More Help, StatCrunch. Okay, stat, proportion stats. This time we have two samples, and we have a summary because it gave us the number and the percent. Okay, now we don't have the number of successes, so we're just going to do a little calculation. For vinyl, 62% of 294 is how many leaked. So we need to find 62% of 294, and that can be just done by multiplying 0.62 times 294. Okay, and round to the nearest whole. And 294 observations. Okay, number of successes for latex, it said 14% of 294, so multiply 0.14 times 294 and you get 41. Okay, and we're testing that P1 is greater than P2. Okay, so our test statistic is the z-stat, and the p-value, see how it says less than 0.0001? That means we can just put 0 there. Okay, it said less than that, so we can just put in 0. Okay, because it's going to ask us to round to 2 or 3 decimal places. So z-stat is our test statistic and p-value. Okay, and put those in. And your answer asks whether or not it's significant. Remember, you reject if the p-value is less. Okay, you reject if it's less than. Okay, number 2, we're going to test a mean. Okay, so we have two separate groups, a treatment and a placebo. It gives us the mean and the number in the sample, and the X with a line over it is our sample mean. Okay, S is our sample standard deviation, and N is the number in the sample. Okay, and it says test that the two samples are from the populations with the same mean. That means we're testing that mean of group 1 is equal to group 2. Okay, it said test that they're the same, that means equal. So when you test that they're the same, that they are equal, it's always not equal. So Get More Help, StatCrunch. We're going to input those numbers from the table. Stat. Okay, now it said that they don't have the same variance, so that means we use t-stats. 2 samples, we have 2 separate groups with summary because we were given the mean and standard deviation. Okay, sample mean is the X with the line over it, that's X bar. Sample standard deviation is S. Sample size is N. Okay, so sample mean is X bar, sample standard deviation is S, and sample size is the N value. Okay, and what were we testing? That it's equal versus not equal. Okay, now it says M1 minus M2. If two things are equal, when you subtract, they equal 0. Okay, so you're testing that they're equal to 0, the subtraction. Okay, like if two numbers are equal, when you subtract, you get 0. Okay, so there's our test statistic is the t-stat and our p-value. Okay, and it also asked, state the conclusion. Okay, see how the p-value is more? That means we fail to reject, there's not enough evidence. Okay, fail to reject, there's not enough evidence. When the p-value is more, there's not enough evidence. Okay, did that ask that in question 1? Maybe I just didn't scroll down. There we go. Okay, back to question 1. The p-value was less. Okay, p-value is 0. It's less than the significance value of 0.10. When the p-value is less, you reject. There is enough evidence. Okay, let's make sure we finish number 2. Okay, how to find a confidence interval for the two. Okay, since it said 0.05, we're going to use a 0.95 significance because 1 minus 0.05 is 0.95. Okay, so back to StatCrunch. Actually, let's go back up here. Okay, I've already got those numbers in. So I can go to Options, Edit. This time click Confidence Interval and hit Compute. Okay, lower limit and upper limit are your answers. Okay, you see how 0 is in that interval? That means they're probably equal. Okay, the reason we're using 0 is because if two numbers are equal, then when you subtract, you get 0. Okay, so this also confirms what we did up here, that it does not seem that there's any difference between the two. Okay, 0 falls between the negative and the positive, so that means the two things are probably equal. Okay, so this time we have two groups that are two measurements before and after. Okay, so this is a study about using hypnosis to reduce pain. So people rank their pain level before hypnosis and after hypnosis, and we want to see if it works. Okay, so this little box we're going to open. We're going to open this in StatCrunch. So it opens our data. Now these are what's called matched pairs. Matched pairs means you take two measurements from the same person. Okay, or it could be a thing. Okay, we're taking two measurements from the same person. So row 1 represents person number 1 ranked their pain at 7.3 and after at 6.9. Okay, so there were 8 people, there's 8 rows there. So this is called matched pairs. So we used t-stats with paired data this time. Okay, sample 1 is before, sample 2 is after. Okay, so if this works, before should be more. Okay, if this works, before should be more. Their pain before should be higher if hypnosis works. Okay, and whatever confidence level it said, your lower limit and your upper limit is your answer. Okay, does it seem to be effective? You see how 0 is in that interval? So the answer is no, because the interval includes 0. We're saying that before minus after, the confidence interval, we're saying that it could be 0. If before and after are the same thing, then it didn't do any work. Okay, and that's the end of our lesson.